Welcome back everyone to Học Tiếng Anh với Joseph, where we build our vocabulary and practice some pronunciation through reading. Hôm nay chúng ta sẽ đọc truyện thứ 5 trong cuốn The Cat in the Box, A History of Science in 100 Experiments. The star of the show is William Gilbert, 1544 to 1603. Measuring the magnetic field of the Earth. If you were looking for a key date to mark the transition from superstitious and mystical view of the world to the scientific study of our surroundings, you could do worse than pick 1600, the year in which the first book based solely on scientific experimentation was published. The book was called De Magneticist Corporibus et de Magno Magnete Detlure, concerning magnetism, magnetic bodies, and the great magnet Earth, usually shortened to the Magnete. And it was the work of an Elizabethan physician scientist who had spent years studying magnetic phenomena. William Gilbert had been born in 1544, studied at Cambridge, and eventually became a court physician, first to Elizabeth I, and then to James I of England and VI of Scotland. As a wealthy gentleman, he was able to indulge his passion for science as an amateur, but reportedly spent £5,000 of his own money on this hobby. He died probably of bubonic plague in 1603. Some of the most important experiments carried out by Gilbert concerned the magnetism of the Earth. At the time, seafarers were opening up the exploration of the world, and the magnetic compass was an invaluable tool. Although nobody understood how it worked, Gilbert discussed the behavior of compass needles with ship's captains and navigators, and disproved by experiment many superstitions, such as the idea that a magnetic compass could be desensitized by rubbing it with garlic or even by garlic breath. He then worked with naturally occurring magnetic rocks called lodestones, shaped into magnetized spheres that he called terre, meaning little earths. He studied the magnetism of these spheres with magnetized needles, which could be moved around the spheres. Gilbert showed that these behaved like compass needles at different places on Earth, and concluded that the Earth had an iron core that behaved like a bar magnet, with a North Pole and a South Pole. Before he carried out these experiments, philosophers had argued that compass needles pointed north because they were attracted to the pole star, or alternatively, that there was a large magnetic island at the north geographical pole. All of this represented a dramatic scientific leap forward, which is so obvious to modern eyes that it is hard to appreciate its revolutionary nature at the time. Gilbert regarded these terre as models of the real Earth, and accepted that the results he obtained, for example, in the way the angle of depth of a magnetized needle depends on its place on the magnetized sphere, could be scaled up to tell us what the earth itself is like. He was extrapolating from models to the world at large, a key feature of science in subsequent centuries. As a result of these experiments, Gilbert was the first person to appreciate that because magnetic opposites attract. The end of a magnet that points northward toward the north magnetic pole of the Earth ought to be called the South Pole. In modern language, scientists sometimes refer to the north-seeking pole and the south-seeking pole of a magnet to avoid this confusion. Gilbert said, all who hitherto have written about the poles of the lodestone, all instrument makers and navigators are egregiously mistaken in taking for the north pole of the lodestone the part of the stone that inclines to the north, and for the south pole the part that looks to the south. This we will hereafter prove to be an error. So ill-cultivated is the whole philosophy of the magnet still, even as regards its elementary principles. Indeed, it was Gilbert who introduced terms such as magnetic pole and electric force into the language. He was the first person to realize that magnetism and electricity, a word he invented, are separate phenomena, and his work on magnetism was not improved upon for 2 centuries until the work of Michael Faraday. Gilbert's book caused a sensation in its day. It was highly influential. Galileo was one of its readers and commented favorably on it in a letter to a friend. Indeed, Galileo described Gilbert as the founder of the scientific method. In Gilbert's own words, in the discovery of secret things and in the investigation of hidden causes, stronger reason are obtained from sure experiments and demonstrated arguments than from probable conjectures and the opinions of philosophical speculators. That is science in a nutshell. And in his book, Gilbert was careful to spell out every detail of his experiments so that other people could carry them out and see the results for themselves. But he cautions whoever does this to handle the bodies carefully, skillfully, and deftly, not heedlessly and bunglingly. When an experiment fails, let him not, in his ignorance, condemn our discoveries, for there is naught in these books that has not been investigated and again done and repeated under our eyes. That's the end of story number 5. Now we will turn our attention to some of the vocabulary we need to practice. And today is really funny because the word magnet appears all the time, a lot of times. Magnet, magnetism. Oh, for some reason I cannot get it going. But in any case, if you go back, you will hear magnetism, magnet, magnetic, and so on. It's the same kind of, it has the same, they have the same root, but they pronounce quite differently. Okay, so as usual, I do have a little bit of a clip from YouTube about Gilbert.
Tell you a story about the electric vocabulary. It all begins over 2,600 years ago. An ancient Greek called Thales of Miletus is thought to be the first person to observe what we would today call electrical phenomena. He discovered that a piece of amber, when rubbed with fur, could pick up small pieces of straw. In Thales' language, amber was called electron. For a long time, that was pretty much all anybody knew about the subject, and nature had to wait around 2,200 years before any investigations were made into amber's properties. William Gilbert, a 17th century English scientist, discovered that with careful experimentation, a number of other materials could display the attractive properties of amber. He also found that they could attract objects besides straw. Gilbert named these amber-like objects after the Greek for amber. He called them electrics. About 40 years later, in nearby Norwich, Sir Thomas Brown carried out similar experiments. He didn't figure out anything different from William Gilbert, yet the way he described the experiments coined the word we use all the time. The way he saw it, when you rub, say, a crystal with a cloth, it becomes an electric object. And just as we speak of elastic objects, and say they possess the property of elasticity, electric objects possess the property of electricity. The 18th century French physicist Charles Dufay was the next person to make an important new discovery. He found that almost any object, except for metals and fluids, could be turned electric after subjecting them to a combination of heating and rubbing. In addition, he found that when two electrics are placed near each other, they sometimes attract and sometimes repel. With this extra knowledge, Dufay found that there were two distinct groups of electrics. Any two objects from the same group will always repel, while a pair of one from each group will always attract. Despite these new discoveries, Dufay's descriptions of the physics are all lost to history. Instead, it is the vocabulary of a charismatic young American that we still remember and use to this day. Benjamin Franklin heard of the work going on in Europe and started his own playful experiments. He quickly learned how to make electric devices that would de-electrify by producing very large sparks. Keen on mischievous pranks, Franklin would often shock his friends with these machines. As he built more effective devices, he likened the act of electrifying and de-electrifying to charging and discharging weaponry. It didn't take long for Franklin and others to realize that it was possible to link these weapons of mischief together. Franklin, continuing with the metaphor, likened this grouping to cannons on a ship. The gun deck on a military vessel fired their cannons simultaneously in a battery. Similarly, this electric battery would discharge all at the same time, causing large sparks. This new technology raised an interesting question. Was a lightning cloud just a large electrical battery? Franklin's description of all this was as follows. He supposed that there is a substance he called the electrical fluid that is common to all things. If, say, a person rubs a glass tube, this rubbing or charging causes a flow of this fluid or an electrical current to move from the person to the glass. Both the person and the tube become electrics as a result. Normally, if the person was standing on the ground, their electrical fluid would return to normal with an exchange from the common stock of the earth, as Franklin called it. Standing on something like a wax block can cut off this supply. Franklin said that an object with an excess of this fluid was positively charged, and something lacking this fluid was negatively charged. When objects touch or are near each other, the electrical fluid can flow between them until they reach a balance. The bigger the difference in the fluid between the two objects, the larger the distance the fluid can jump, causing...
Well, I hope you enjoyed part of this clip. If you want to find out more, just enter Gilbert, William Gilbert, in the search engine, in the video section, you will find it. I think it's part of TEDx program. In any case, have a wonderful day, and thank you for your time, and I'll see you in the next story. Bye for now.